For correlation and regression wisdom number 2, I want you to look at these 4 scatter plots. Which one do you think has the strongest correlation? Well, people might argue different values, but it turns out, in fact, that they all have exactly the same correlation. And furthermore, even more oddly, they all have the same regression equation. A statistician made up this data to illustrate an important point, that you can calculate the correlation and least squares regression line for any relationship between 2 quantitative variables, but the results are useful only if the scatter plot shows a linear pattern. It turns out the regression equation for all of these equations has a y-intercept of 3 and a slope of 0.5. And if I were to graph the regression line in all of these sets of data, it looks pretty much like this. Okay, so I'm kind of, and sort of like that. So it turns out, actually that one's probably a little off. Turns out kind of like that. So if I were to use this line to predict a y value using an x value, notice that the only one that gives me reasonable predictions would be graph number 1. Graph number 2 clearly has a curved model rather than a straight model. Graph number 3, the line is too high for most of the x values and then kind of too low for that one. That outlier has a strong influence on the graph. Otherwise the graph would fit nicely with the rest of the points. And here, this graph really doesn't make sense for these data at all. We have this vertical line and this one outlier over here. So the results are useful only if the scatter plot shows a linear pattern, and you might also want to add with no extreme outliers, because the outliers actually have a great influence and can cause a model to not be appropriate for the rest of the data. So the moral of the story is here is always check the graph when using linear regression and correlation.